Hey guys, this is Mr. C, and I'm going to show you in this video how to graph lines that are in standard form. And so we all know what slope-intercept form is, right? Here's slope-intercept. Slope-intercept. Okay, that is y equals mx plus b. M is the slope, b is the y-intercept, right? Y and x, that's your dependent variable, there's your independent variable. These are really easy to graph. We already did a video on that. That's no problem at all. Everybody can graph a line in slope-intercept form. However, what if those lines do not look like this at the very beginning? So let me give you a line that does not look like this, but it's still a line. And I'll do 3x minus, let's do 5y equals 15. A lot of times you'll get lines like this where these two coefficients here are both factors of the constant over here. That's for a reason that I'm going to show you here in a second. So normally a student, when they get this, they think, well, I need to graph this. I could make a table of values with x and y, choose an x value, get the corresponding y value, and then plot the point, right? That's really labor intensive and it takes a while. And you can do it that way, no problem. But there are easier ways to do it. And so the first time a student gets one of these, their teacher usually tells them to solve it for y, and then you'll get it in slope-intercept form. So let's do that real quick. If we solve this for y, we need to move the 3x over first, right? Minus 3x. And then additive inverses cancel out. Negative 5y we bring down equals negative 3x and then plus 15, right? Then you divide everything by negative 5. Divide by negative 5, divide by negative 5, and divide by negative 5. If you do that, those cancel out. Those are multiplicative inverses. So y equals negative over negative is positive. 3/5 x. 3/5 x. And then this plus and minus, so the minus wins. Minus 15 divided by 5 is 3, right? Now this right here is really easy to graph. This is in slope-intercept form again. Your slope is 3/5, is positive. Your y-intercept is negative 3. But you do have to go through all of this rigmarole every single time if you want to do it that way. So what I suggest is taking a line that's in standard form. Here's standard form. ax plus by equals c. That's standard form. Now that's really good for things like solving systems of equations with elimination and substitution. That makes it a lot easier, and I'll do videos on that later. But for graphing, this really isn't the best way to graph a line. You don't have y by itself, and you don't clearly see what the slope and the y-intercept are. A, b, and c for standard form are all integers. The a is positive, okay? So I'm going to solve this for y just to see what happens. So I'm going to put negative ax here, kind of just like I did it before. Okay, those cancel out. Bring down my by equals negative ax plus c. Okay, again, same as I did before, except I just have a b here. It could be anything really. I'm going to divide everything by b. Divide by b, divide by b, divide by b. Cancel. So now y is equal to negative a over b x plus c over b. Now by doing this, what I've done is I've generalized how to turn a standard form equation into a slope-intercept equation. And now I know that every single time my slope is going to be negative a over b and my y-intercept is c over b. So if I just know these three numbers right here, I can calculate my slope and my y-intercept quickly. And on the ACT, you have to do that quickly because each question, you only get a minute on the math part. So I'm going to use this, I'm going to exploit this relationship here to get my answers very, very fast. All right. I'm trying not to go too fast, but I do want to show you the speed that we can accomplish these problems at without having to do all of this every single time, because that's just going to get annoying. So first thing I want to do is I want to show you a little graphic organizer. So this should be a little graphic organizer that you should have in your notes when you start graphing lines in standard form. So, I mean, why do we even graph lines in standard form? Well, for me, I mean, really, it's not a great way to graph a line. I'd rather just do it in slope-intercept. But when you take an EOC or you're in college and you take these tests, you know, they're going to give you tons of these equations to graph just to see if you can do it, especially on the EOC. So I like to just get practiced, and that way it's going to be easy. So again, I see that my slope is going to be negative a over b. Now what really trips people up is that negative right there, that extra negative. Really messes people up. The y-intercept, very simple, c over b. So if you think about it, these two guys make the slope and just add a negative, and these two guys make the y-intercept. And you don't add a negative there, it's just whatever they are. Very, very simple. Once you get used to this, you can do these problems without doing any work on here when you're just finding the slope and y-intercept. And that's really our goal at the end, is to be able to do this quickly and efficiently. So let's look at some examples that we've got. And our first one, let's do this one. And so we have graph x plus y is equal to 2. All right, so we do not want to solve this for y, even though it'd be real easy in this one. What we're going to do is come up with the slope and the y-intercept quickly. So let's get our a, b, and c values. Our a is 1, right? Because that's just a 1 in front of x. So a is 1. Our b is 1, positive 1 in front of y. Our c is 2, positive 2. Okay, so what's our slope? So the slope is negative a over b, right? Well, what would that be? Negative 1 over 1. I don't really need to simplify this, you know, unless the numbers are really big and they have common factors. I could just leave it like that. That's fine. What's my y-intercept? Well, that's easy. 2 over 1 is just 2, right? And I could have written c over b, but that's okay. 2 over 1 is equal to 2. Most people don't have any problem with this. This is where they have the issue, okay? So now let's take a look. I'm going to start at 2. I'm going to go down 1 over 1 to the right. And I'm going to stop there for a second because this is really going to be weird for people. They're going to see that plus right there and think, oh, the slope should be positive. No, the slope is going to be negative. Why is that? Because the extra little negative right there is going to make it negative. So whenever I see these two numbers, a and b, as both positive or even both the same sign, then I know that my slope is going to be negative. But that's because I've done a bunch of these. So we'll just do a few examples and see how this works out. So again, we're going down 1 over 1, over and over again until we get to the end of our graph. Right there. Back 1 up 1, just like we did in our slope-intercept video. And then we're going to connect our points with our straight edge. And again, I'm crazy about straight edges. Got to use one to graph a line. And then there's your line. Not a problem, right? Okay, let's do another example. Okay, this one now, we have x minus y is equal to negative 1. All right, let's take a look. A is 1. B is negative 1. C is negative 1. Okay, so let's take a look at our slope. Our slope is negative a over b, 1 over negative 1. Well, these two negatives are going to make a positive. So this time I'm not going to leave it like this because two negatives, I don't want to leave both those negative right there. That's going to be confusing. So I'm just going to change that as just a positive 1. So my slope is going to be going up 1 over 1. My y-intercept is negative 1 over negative 1. And that's going to be positive 1 as well. So this guy, even though it does not look at all like that's what's going to happen, that is exactly what happens because of the structure of this equation in standard form. It's going to start at 1. And I've seen a lot of students start at negative 1 because they look back at here. Don't do that. Start at 1, up 1 over 1. And you're going to get all of the rest of the points on your line. All the way back. Just finish the pattern out. The more of these you do, the better you get. Take your straight edge, connect your points, and there's our graph. All right, let's look at our next one, see what we got. Okay, this time we have 2x plus y equals 2. All right. Eventually, we want to be able to do this without having to list a, b, and c out. But if this is our first time doing this, or our memory is not that great like mine, then we might want to list them out. So let's do that. And I think I'll put them at the top here this time. So what's a? A is 2, right? I got a little bit more room up here. B is 1. And c is 2. Okay, so what's our slope? Always put your negative first. 2 over 1. So that means we're going to be going down 2 over 1. We can leave it like that. That's okay. Y-intercept, 2 over 1. And that's equal to 2. So we're going to start at 2 on the y-axis. We're going to go down 2 over 1 to the right. Again and again. And then go back 1 up 2 to finish the pattern. And there's our line. We'll go ahead and connect our dots. That's pretty good. And there we are. All right, not a problem. Okay, let's do another one. This time we have 3x plus y is equal to 2. Okay, what's our a value? 3. What's our b value? 1. What's our c value? 2. Okay. All right, let's check it out. Slope, first, m is equal to negative a over b, 3 over 1. We can leave it like that. Down 3 over 1 to the right. Y-intercept, 2 over 1. And again, that just equals 2. So we're going to start there. 2. We're going to go down 3 over 1. Again and again. We can't do it again, but remember what I said before. Both of these signs here, positive 3 and positive 1, if a and b are the same sign, it's going to have a negative slope, and that's exactly what happened. Back 1 up 3. Okay, we'll connect our dots. Use our nice little straight edge. And then there you go. There's your line. All right, let's do another example here. Okay, this time, I'm trying to give you all different kinds of examples of weird stuff that can happen, stuff you see on the EOC and in your classes. This one is equal to 0. Okay, that's no big deal. A is 4. B is positive 1. And C is 0. All right, slope first. M is equal to negative. And see how I do that first? That way I never forget that negative right there. 4 over 1. We can leave it like that. Down 4, 1 to the right. Y-intercept, 0 over 1. But 0 divided by 1 is really 0. So our y-intercept this time is going to be the origin. So we put a dot on the origin. We're going to go down 4 over 1 to the right. 1, 2, 3, 4 over 1. We're going to go back 1 up 4. 1, 2, 3, 4. And that's it. That's all we can have on this one before we run out of space. And then we will connect our dots. And then there's your line for that one. Okay, next example. Let's do this one right here. Okay, let's do our A, B, and C. A is 1. B is negative 2. And C is 4. Okay, now slope. M is equal to negative, okay, 1 over negative 2. Okay, so we need to clean that up. We got 2 negatives. So those are going to cancel out, and it's going to make a positive 1/2. So that means we're going to go up 1, 2 to the right. Y-intercept, 4 divided by negative 2. And we can clean that up and rewrite that as just negative 2. All right, so we're going to start here at negative 2. We're going to go up 1 over 2 to the right. And again, and again. We're going to go back 2, down 1. Again and again. And we see that the pattern is going to make a straight line. Those points are all collinear, so it looks good. And we will connect our dots and apply the arrows, and that one is done. All right, got a couple more. Okay, this time, 3x minus 2y is equal to 6. A is 3, B is -2, and C is 6. Now notice, 3 and 2 are both factors of 6, so this one's going to turn out nice. The slope is still going to be a fraction, but at least the y-intercept is going to be a nice number that we can clearly tell where it is on the y-axis. All right, so slope first, m is equal to -3 over -2. Now remember, -3 over -2, right? So these two negatives are going to cancel, and I'm going to get 3 over +2. So now what happens when you get a positive slope? Well, you'll have a mixture of negatives and positives here, and that's why I got the positive slope there. So it's kind of just the opposite. 3/2 is good, up 3 over 2 to the right, y-intercept. Okay, it looks like we got 6 over -2, and that would just be, what, -3? Okay, so we're going to go down 3 to start with, up 3, 2 to the right, 1, 2, 3, 1, 2. I'll stop there for a second. We call these 2 points right here, since these 2 points cross the x and y axis, we call these intercepts. I'll be making a video later also that only focuses on how to get the intercepts, and that's another way to graph a line that's in standard form. But to do it that way, these two numbers definitely have to be factors of the constant. A and B have to be factors of C to be able to use the intercept method, to be able to use it efficiently. So I'll talk about that in another video. All right, so let's keep going. So up 3 over 2, right? Up 3 over 2. Okay, up 3 over 2 puts me in the corner. Back 2, down 3 completes the pattern. Connect our dots. So what happens if our dots don't all line up? Well, we did something wrong and we have to do it again. It happens. But this one didn't. Those all look pretty good. All right, let's try another one. Okay, again, we have a 2, a 3, and a 6. I've got some changes here, though, from the last one. This time, A is 2, B is 3, and C is -6. The reason why you want to take the same 3 numbers but change up the signs is to see what happens when you do change up these parameters, when these are negatives or positives, or that's a 3 and that's a 2. And then when you notice those things, you start to see how these functions and these equations are going to behave before you even get to the graph. You can make predictions that way. So slope, -2 over 3, and again, we're the same, so we have a negative slope, so I'll just leave it. Y-intercept, -6 over 3, and that would be a -2. So this time we start at -2, and we're going down to 3 to the right. Down 2, 3 to the right, down 2, 3 to the right, back 3 up 2, back 3 up 2. We see again, 2 and 3 are both factors of 6, so we do have our intercepts right here. That's for another video, but it's a good thing to notice. We'll go ahead and connect those points, and then we got a couple more to do. When you're doing math, the more examples, the better. You want to see as many as you can. All right. We look at this one, let's size it up. 4 and 3 are both factors of 12, so we're going to have intercepts that are nice. We have a positive there and a negative here for A and B. That means my slope is going to be positive. So let's see if that checks out. A is 4, B is -3, C is -12. All right. So M, slope, -4 over -3. 2 negatives cancel. That gives me my 4/3. Okay, so up 4 over 3 to the right. Y-intercept, -12 over -3, which is actually going to give me a +4. So I'm going to go up 4 this time. 1, 2, 3, 4. Stop there. And I'm supposed to go up 4 over 3, but immediately I go off the graph, don't I? So I'm running into one of these weird ones where the graph is not really big enough to handle the next point over this way. So I'm kind of forced to go backwards. So instead of going up 4 over 3, right, I need to go down 4, back 3, right there. Now, how do I know that that's correct? That I did that correct? Well, if I look at the coordinates of this point right here, the coordinates of this point are going to be negative 3, 0, right? When x is negative 3, the corresponding y value is 0, right? So is that going to be true? Did I do that correctly? Well, let's see. First of all, when x is negative 3, right, I'm going to get, let's see what I got here, 4 times negative 3 minus 3y is equal to negative 12. So here I have negative 12 minus 3y equals negative 12, right? So what's going on here? So if I subtract 12 from both sides, I'm going to get negative 3y equals 0, right? Now, at first glance, you might think, well, there's no way that that's going to be 0. But as soon as these negative 12s cancel out, negative 3y is equal to 0 forces y to be equal to 0. Has to be true. So I do have the coordinates to that point correct. And if I look at the slope, it does go up 4 over 3 to get my next point. So it does work. It gives me the correct y-intercept. So I'm going to go 1, 2, 3, 4, 1, 2, 3. I'm going to grab that point, and then I'm going to connect my points. And there is my line right there. All right. So let's take a look at this one. Okay, and this one's kind of interesting. Look at this one. The first thing that grabs my attention is that 3, 6, and 6 are all divisible by 3. Now, you can divide that 3 out immediately if you want to. A lot of students, when they first do this, are not even going to look at that. They're going to go right to the procedure. They're going to say A equals 3, B equals 6, and C equals 6. And that's not a problem because you're going to get the correct answer anyway, but you'll have to simplify your slope and your y-intercept coming up here. So let's talk about slope. That's going to be negative 3 over 6. Now, you see how that simplifies to 1/2? So negative 1 over 2. Okay, so let's look at our y-intercept. You've got 6 over 6, but see how that simplifies to 1? And that's what you would have gotten if you would have taken a 3 out of all 3 of those. So let's deal with it. 1 right there, down 1 over 2 to the right, down 1 over 2 to the right. Keep going. Go back 2 up 1, back 2 up 1, one more time. And here's our line, and all of those points right there are testable. If you want to test them in your equation to see if they are solutions, they all should be. Not a bad thing to do when you're first starting out, but a bad thing to do when you have time constraints here like I do right now, but it can be done. And our last example, 5, 3, and negative 15. All right, so this one, 5 and 3 are both factors of negative 15, so I'm going to predict, number 1, that they're going to have intercepts that are nice. I'm going to predict also, I have a positive and negative here, so I'm going to predict that my slope is going to be positive. And since these are both negative, my y-intercept is going to be positive as well. So let's check it out. A is equal to 5, B is equal to negative 3, and C is equal to negative 15. All right, so slope is going to be negative, don't forget that, 5 over negative 3, which is in fact positive 5/3. So I was correct on that. My y-intercept is going to be negative 15 divided by negative 3, which when you divide those turns out to be positive 5. So I was correct on that. My y-intercept is positive. So I'm going to go up to 5. 1, 2, 3, 4, 5 here. Put my dot. Again, I can't go up 5 over 3, so I'm going to have to do the next best thing. I'm going to have to go down 5, back 3. 1, 2, 3, 4, 5, 1, 2, 3. Now, why does that work that way? Because to me, I would be kind of skeptical. How'd you know to go down 5 over 3 to the left? Well, let's take a look at that real quick. Here I have 5/3 as my slope, right? That means up 5, 3 to the right. However, that is also equal to negative 5 over negative 3, which are just the opposite. So instead of going up 5, I go down 5. Instead of going 3 to the right, I go 3 to the left. And it makes perfect sense because these two fractions are equivalent. So I am correct and going down 5, back 3, and that is going to work. Again, 1, 2, 3, 4, 5, 1, 2, 3. Okay, there's my point right there. And now I'm going to connect my dots. And there is my line. So remember to like and share and subscribe to my channel. Not that I'm making any money at it, but it just kind of helps to go back, because there are apparently several David Cochrans in the world, and I'm just one of them. So if you have any suggestions or you have any questions, feel free to leave those in the comments, and I can make a follow-up video. Or if it's easy enough to answer in the comments, I'll just do that. All right. And we will see you later, guys. Bye.